Hey people, here's some practice problems for some separable first-order differential equations. We'll do like 4 easy ones to start off. And, make sure you pause and try them yourself. So our first one is y prime equals negative 2x y squared, which is the same as dy dx equals negative 2x y squared. And we want to get the variables, the similar variables on their own side. So we're going to divide the y squared over, and we're going to multiply by the dx. So now we have our variables on each side, so we integrate both sides. And remember, this is the same as y to the negative 2. So on the left, we get y to the negative 1 over negative 1. And we leave our constant on the x side. Negative 2x squared over 2 plus c. We only need to have it on our independent variable side, that's c. So then we can cancel those out, multiply by negative 1, and this is actually 1 over y. Multiply by the negative 1 through, so that negative goes away. Get x squared minus c. And then we need to solve for y, so we're going to multiply the y over. Then we'll divide by x squared minus c. So we get a final answer of y equals 1 over x squared minus c. That's the answer to the first one. The second one is a pretty famous population growth problem. So we have dp dt equals k, which is a constant, times p. So the rate of change of growth is some constant times that whatever the population is at that time. So we need to multiply the dt over and divide the p over to get the variables on their own side. So k is a constant times dt. And we're going to integrate both sides. We get natural log absolute value of p equals kt plus c. And then to solve for our p, we need to exponentiate. So take e to that so we can get rid of that natural log. And we're left with p. And then remember our exponent rules, so this is actually times e to the c right there. And so that we get e to the kt times e to the c. Because this is another number, we can call this whole thing another constant. So we can just call that c. And then because it's multiplied, it's kind of a trick where we say that that c kind of takes care of both the negative and the positive. So we can actually drop these absolute value signs. So we get p, or p of t. And then this e of c, we can bring it out front, equals c times e to the kt. So that's where exponential functions with growth or population comes from. That's why you see e's within those. All right, we'll do 2 more. And then how about we got y dx minus x minus 2 times dy equals 0. So we need to have things that are multiplied with each other. We need to have functions that are multiplied, so we need to get rid of this minus. So we'll just add this whole chunk over to the other side. And then we have functions that we can divide and multiply. So we will divide by x minus 2. And we'll divide that y over. So that gives us natural log x minus 2 when we're integrating plus c. And we see lots of natural logs and exponents pop up in separable differential equations. It's just kind of the way it is. So, it's a good idea to know your natural log rules and your exponent rules really well for this. And so we need to exponentiate again because we need to solve for that y. So that's another, remember our e to the c again. So it's kind of the same idea where that c can kind of take care of the absolute values. So this is just another constant again. That's just a c. So we actually wind up with c x minus 2 equals y. And because that c is multiplied through, we can also take the absolute value off of the y as well. So that's our final answer for that one. All right, and last one, e to the x plus y dy minus dx equals 0. So this is the same as e to the x times e to the y dy. We'll add that dx over. And then we can divide by the e to the x. Over e to the x. Then integrate. Get e to the y equals, and then this is the same as e to the negative x. If you can see that a little easier. So we get negative e to the negative x plus c. And then we're going to take the natural log of both sides to solve for that y. So we get y equals natural log. This one we actually need to keep the absolute value because these are just, the c is just added. So we can put it in front, c minus e to the negative x. And we'll keep those absolute values there. All right, that was 4 quick and easy ones. Hope that helps. And see you on the next one.